Hello. Let's talk about getting that wall layout off of a set of PDF plans. We need to do a takeoff. We need to know how much block we're going to have, how much geogrid, how much excavation the contractor is going to have. So, short video, getting the wall layout. First thing we have is somebody sent us a plan view. Could be a large PDF, could be a small, but we found the wall. So there's the wall that lays in. This is a proposed building, the parking lot that comes around, little slope out in front. The adjacent property line is over here. The scale of the drawing is 1 inch equals 20 feet. We've got a scale bar up here. And we know it's retaining wall because we've got top of wall, bottom of wall called out all along the wall. Sometimes it will say proposed wall, sometimes not. Sometimes maybe you won't find the top of wall, bottom wall. Like it's called out here, you're just going to find the grades in here, the elevations. So, we know that the parking lot is at 582, 583, grading this way to 581. We know the bottom of the wall, that's around a 580 contour. As we move over here, we can find out what these contours are. But for right now, let's just work on those values. So I've got the numbers. Let's go to the program. And first thing we're going to do is we're going to say, call it the new office building. Initials in here, who did it, Minneapolis. This is just information, something that we have for the project, but there we're set up our block information. We're going to design this with an SRW. We'll go with CornerStone 100. We can design it with SRW products. I don't have a primary selected, so I'm going to go with a primary of 3, a second primary 5, secondary of 3. This being a stronger grid, this being a weaker grid. We look at the connection curves. The 5 and the 3 are way down here. Kind of low strength products. We could move up to the 7, 9, 11. Move up to this curve to give us more capacity, but let's see what happens. So those are set up. We'll save the grid selection. This is all good. Okay, so now let's go to let's bring that plan view in there. So we go to plan view. We'll expand this page out, and I'm going to bring it in as a PDF. So it's up on my desktop. Sample plan. Got to bring that in. There it is. It's scale it. There's the scale bar up there. Let's see what our scale is. So we go to our ruler, go to 0, go to 40. It scales out 4 feet, not to scale. Okay, so now we come in and scale the drawing. Well, I've still got the scale bar up here. I scale the drawing. That measured length was 40 feet. What the plan said, I'm going to do it to 1 to 10 scale, 1 to 240 inches. The scale is, the plan is now scaled. If I go and I check that again, I go from 0 to 40, measures 39.58 feet. Probably about as close as I can get. I could probably squeeze that number over a little bit. But it's scaled. We're good on that one. Now, that's my retaining wall. This is the downside. This is the front side of the wall down here. The lower side, the parking lot's on the upper side. With that, when I draw the walls up, I want the beginning at the left, the beginning of the wall, to the end of the wall, and that's the way it's going to go on the plan. So I'll come in here, I'll pick a P-line. Now every place I have an elevation change, I'm going to click. So I start the wall, I'm going to click there, I'm going to click there. Nothing through here. I got one at the corner. I got one over here. I got one at this corner. And I'm going to put one at the top of the stairs and one at the bottom of the stairs. I'll double click, we'll end that line. There we go. Blue lines mean it's selected. I go to the properties. I like to make the line red so that I can see it, and I like it to thicken it up so I know where it's at. So there's my line, there's my wall. I'm going to come down here next. I'm going to say get properties, get points. This dialog comes up. We can shrink that down, put it down here somewhere. And let's number the points because I go along, I don't want to lose where I am. So I'm going to number the points. 0, 1, 2, 3, 4, 5, 6, 7 points. I'm going to reselect that line and I'm going to say get points. So now there's the XY coordinates of all the points, and now I just work my way along the line. So 583, 581, hit the right key here, 581, that's my first point. The second point, 582.5, 579.3, point number 2, 582, 577.25, point number 3, that being up here, 581.5, 571.5, point number 4, that's down here, 582.75, 574.5, point number 5, it's up here, 585, 575. Point number 6, I don't have any coordinates over here. You know, I could pull my grades off of here for the ground elevation. I know the top's going to be the same, but I'm going to say, let's assume it's the same. So I'm going to put in 585, 575. For this point, number 6, the 7th point, that's one at the bottom of the stairs, the grade there is 578. Point something, 578.0. So 578, 578. I come back and I look at this. Point number 2 is a corner. So point number 012, that's an outside corner. Point number 3 is an outside corner. And then point number 5 is an outside corner. That's just giving us a reference to the drawing of, you know, what we're looking at. So there's our input points. That's all we can do on this plan. One last thing I can do, I say plot coordinates. The line is selected. I can set plot coordinates. Little dialog box that say that station's 73.4 feet. The top's 582. The bottom's at 577. The nice thing with that is we can check it against what the grades were on the plan. So as you're checking plans, it's 112 feet, 581, 570. It's a good check as we move along the wall. The whole wall is 234 feet long. Let's send it to the drawing. Let's send it to the analysis program. So it's gone over there. Now we go to wall layout. There's all of our input points. That's our X coordinates. Top of wall, bottom of wall. This is good. We go back and look at the plan. Okay, I've got a parking lot on top of here. A little greenery area in here, parking lot up there. So to be conservative, I can say I'll assume it's a parking lot. So we'll go back to the wall layout. It's going to be a live load. I'm going to put a parking lot at 150 pounds per cubic foot. Say it's 2 foot off the top of the wall, 50 feet wide, and I'll do that all the way to the end of the wall. 150 to 50 foot wide. So now we're designing for the slope or the load that we have above the wall. Look at the plan view again. I don't see much of a slope down below the wall, but I do in here. Kind of a slope. So maybe from station 2 to station, what is that, point number 4, I've got a slope. So I go back to wall layout. from point number 2, 0, 1, 2, I got a top slope angle of, call it, I didn't measure it, but call it 18 degrees, 20 feet long, starts at the top of the wall. At that point, we were zeros. Point number 4, 0, 1, 2, 3, 4. I had a slope in there of 18 degrees, 20 foot long, 0 offset. And then at this point, we've got 0 slopes. So, I mean, we could go back, refine that a little bit, but just for now, that gives us our live load above the wall for the full length of the wall. That gives us our slopes as we move along the wall in how we're going to input. So, let's go to how the wall is going to be designed. Default data. We're going to design to the NCMA design method. We're going to assume silty sands up there, so 28 and 120. The default batter for that unit is 4.5 degrees, no tilt, 6-inch thick leveling pad, minimum embedment 6 inches, and then I use 10% height to depth ratio. NCMA is an AASHTO R 5% minimum with H over 10 for 3-to-1 slope, H over 7 for 2-to-1 slope. These are slopes in front of the wall. Slope embedment, if we go to AASHTO, Federal Highways, NCMA, they're recommending 4 feet to daylight. So that will embed the wall more. Defaults for an MSC design, reinforced design, 60% base to height, measured from the face of the block, 4-foot minimum, maximum grid spacing, 2 times the depth of the block, or 2 feet. I've got 2.67. It doesn't matter. The program will always default to 2 times the depth of the block, so which is going to be 2 feet. And this will drop back to that. If I want to reduce the spacing to every 2 blocks, I could put in 1.5. But let's leave it at 2. These are drawing units for 1 inch equals 10, the height of the text above the wall, and the size of our target when we draw the wall. So this is how the wall is going to be designed. Our input data's input. Our defaults are fixed. Let's shrink this down. We'll move this down to this lower corner. Let's draw the wall. This is a design check. Have we checked for surcharges above the wall? Yes. Slopes, yes, we have 1. Surcharge, we have nothing. And it's a reinforced design up here. We can hit proceed, or you can hit skip, which just goes through this, either one. Goes through, now we draw the wall up. Progress bar comes across. And there's our wall layout. So that's a station 0. Remember, we came along the side of the parking lot. There's our outside corner. That's that first turn. The wall gets deeper. That's our second turn. And now as we come back up, we can hit the pan button up here. Then we move to the end of the wall, and these are the stairs coming down. Came down and we hit the stairs. The grade's going up, the stairs are coming down. So that's how our wall terminates in here. That looks about right. One thing we can do is the top of the wall was stated to be on the plans at 583. The finish grade at finish grade in front of the wall at 581. The program drew it at 583.47. What I like to do is get it to even feet so I can come back into wall embedment, calc vertical. The desired top of the wall is 583, this number here. It's drawn at 583.7, that number there. So that means I've got to move the wall down 8 inches to match grade. So let's put that in there. Let's draw the wall again. Okay, there's a new wall layout. Let's see what we have up here. Well, didn't quite hit our grade. Why not? Just the way the wall was stepping up. All right. Probably what I'm going to say is, yeah, we'll come back to that. Anyway, so there's the wall layout. As we come to the deeper part of the wall, because our wall's getting taller in here, the embedment's getting deeper. Because we put a slope through this section of wall, our embedment also gets better. It's an 18-degree slope, so it's H over 10, same as my default. There's the outside corner. This is saying the top 3 layers of grid are SRW3. The bottom layers are SR5. 2-block spacing down here. I must need it for the strength of the grid. 3-block spacing up there. That one looks good. Maybe what I say is, hey, I want to keep the spacing up, so I'm going back in here and I'm going to say in my geogrid properties, let's get a little stronger on the grid. Maybe I do something like that. Look at your connection capacity here. This 3s and the 5s are way down here. When I jump up here to the next one, to the 7, now I'm getting another 500, 600 pounds per foot of connection capacity. And that's what's driving the design. So I just strengthened my grids. Let's draw the wall again. See what that's going to look like. Okay, it did. It went from 5s to 7s. Now I've got 3-block spacing all the way up through the wall. A little bit more efficient design. I could come in and adjust grids. We'll do that in a later video to show how it smooths out. Or, what I could say is, okay, let's keep it simple. Let's just design the whole wall with all 5s and use tighter spacing down here, or all 7s, and use a more expensive grid up there. That's your choice as a designer. But got the wall laid out. Looks good. Our embedment looks good. Our loads look good. We've labeled it. Let's look at our quantities. We've got 182 cap units, 1860 in our wall units. I got a half block and a half cap block. So total face square footage of 1953 square feet. I've got 801 square meters of SR5, SRW5. I've got 205, square yards of SRW7. So that's my quantities. There's my blocks. There's my geogrid. Here's our gravel and our fill quantities down here. That's what we're looking for. We'll take off. If we want to check something real quick, let's look at global, make sure we haven't missed anything. So I go to station 115, 115 down here, 112 to 140 in here. There's our parking lot. Whoops, look at this. I put the slope on top of the wall instead of the bottom of the wall. This graphic is great for seeing what you're doing. Let's go back to the wall layout. Boom, boom. There's the slope. I put it on top. It needs to be on the bottom. 20 and 0. I have no slope on top of the wall. 0, 0, 0, 18, 20, and 0. Now I got a slope below the wall. And my surcharge is above the wall. So that one's correct. Let's draw that wall again. Kind of as we plug through this, we got a lot of visuals in here to check things, make sure you're doing it right. A lot of check boxes are going to pop up. So hopefully we don't make a mistake. Let's look at this again. Okay, that went SR5 all the way from top to the bottom. The reason it was going 5s to 7, because we assumed that we had a slope above the wall. We don't. It's level with a traffic surcharge. So now that dropped the tension of the grid. Everything's the same grid laying out. Look at our embedment. So if we pan back here, we said 6 inches minimum, about 1 block height. That's good. As the wall starts getting taller, our embedment starts getting deeper. We're also into where the slope was. So our slope is going to be, h over 10, 4 feet to daylight. Our block now gets deeper. So we're we're about 2 blocks deep, 2.5 blocks deep. This line right here, the upper line, is our finished grade in front of the wall, and the lower line down here is our embedment line. Meaning that to meet that 6 inches minimum or h over 10, the bottom of the units have to be below that bottom line. So that's a good reference also to make sure we have enough embedment. At the top of the wall, this solid line up here is the top grade behind the wall. So you can see that our cap units are stepping above grade. They'll meet it, they'll step above it. So we've got good layout. Our wall is deep enough, our top is good. We've looked at all that stuff. So I checked that. I want to look at global at 115. Go to geometry. I go to 115. All right, this picture looks good. I got a slope below the wall. I'm level with a surcharge above the wall. And my grids are 10 feet from the face of the wall. I look at my static results. Nothing's red in the table, meaning the calculations are good. Overturning is 7, sliding is 2, 0.95 basically 3, bearing is okay. And if we look at global, 1.192. Obviously as an SRW designer, typically the global stability is the responsibility of the geotechnical engineer. But it's nice to look at it and say, did we check it? Is there something to look at? And we want to target 1.3. You got a 1.192. Probably needs to be looked at. I said I got a silty sand in here. Silts with fines, definitely going to have some cohesion. I typically throw 50 pounds cohesion in that. If we update the design with cohesion in it, obviously my factors of safety are going to go up here. Now I look at my global and 1.351. So that's going to be good. Again, this is where you need to go back to the geotech and say, hey, are these reasonable parameters? Typically with a silty sand, a clay sand, you're going to have 50, 100, 200 pounds per square foot cohesion. So I don't feel bad about doing it, but the geotech needs to confirm that. So our static design looks good. Our global looks good. We look at compound. That's greater than 1.3. That's good. The design is good. Now we look at quantities. Our caps, cap units, our wall units, SRW grid. It dropped. Look at this. We got all 161 square yards of SRW5. So that's good. We go back to the plan view. We'll go to maximum view. We'll come here and we'll say we'll print our estimate with the long. We'll kick out 7 pages here. There we go. There's our plan view. Now these are those coordinate points that we put in, so you can check the numbers input, match the numbers on the plan. A good check for yourself. There's our elevation, our wall view as looking from the front of it. That's where we started. Comes down to the corner, turns the corner, second corner, steps up, carries along up to here. There's our input parameters. Remember, we put the 50 pounds in there. There's our leveling pad. There's our face area, our block count if you want up here, or our grid quantity down here. A little fill zone behind the wall, a little discussion of what happens, and there's our input data. So we're good to go on that. We could print that out to a PDF, print it out to a printer, but there's our quantities. We can say save our design, put on the desktop, call it the sample project, and replace it. The file saved, and when it does that, if we go look at the desktop, now looking at the desktop, we see there is our sample plan. We saved, we saved that as a PDF file. We imported that into the drawing file. We designed it, we saved it. And when you save the file, it creates this AutoCAD drawing of the project. So if we look at the AutoCAD drawing, we open it up, there we are. There's the full elevation, there's the run, there's the taller part of the wall. This is in full AutoCAD. If you look at all your layers over here, this is everything we can turn on the block wall. And if you wanted to look at block labels, we could turn those on also. So there's every block in the wall is labeled, but we don't want to see that. So we turn the block labels off, and we turn the block wall, actually I turn the transparency down to about 90. And there we can see the walls, but we can also see where the grid is and where the grid lays out. So there's your project, saved, quantities, layout, AutoCAD drawing, ready to go. So with that, if you have any questions, please feel free to give me a call, send me an email. We can walk through the program, do some samples with you. If you'd like to see something changed, like to see something added, let me know. We can work through that with you. So with that, thank you very much.